Hello friends, today we are going to perform first practical of fluid mechanics. Title of the practical is Redwood Viscometer. Redwood is the name of the investigator who has investigated this apparatus. Aim of the practical is to study variation in kinematic viscosity of given oil with temperature. First of all, what is viscosity? It is the property of the fluid by virtue of which fluid offers resistance to flow of one layer over an adjacent layer. It is necessarily important to determine the viscosity because viscosity accounts for resistance means losses. More the viscosity, more are the losses. Then how to perform this practical? So this is the setup for the practical of the Redwood Viscometer. So this is the apparatus of the Redwood Viscometer. The apparatus consists of this inner cylinder which will contain the liquid whose viscosity variation is to be determined. At the bottom of this inner cylinder there is a hole. That hole is known as orifice. Then from that orifice, from that hole, that oil can flow inside this flask. Then this inner cylinder is surrounded by constant temperature water bath with electrical heater which will maintain the oil inside this inner cylinder at the desired temperature. So additionally what apparatus are required for us is the stopwatch, thermometer and 50 ml flask. What is aim of the practical is to study how the viscosity of the given oil or any other liquid is going to change with respect to temperature. Then for doing the practical, first reading is taken at the room temperature. So what we are supposed to do, initially this cylinder is filled with the oil whose viscosity variation is to be determined. Then by making use of this ball valve, the hole at the bottom is closed so that oil will not flow in this inner cylinder. Then once the temperature is noted by making use of the thermometer, let's say that initial temperature is the room temperature, then we are going to lift this ball valve so that oil will start flowing in this in this cylinder. Then we will measure the time required to collect 50 ml of the oil. In this way we are supposed to measure time required to collect 50 ml of the oil. So once this first reading is over, then what we are supposed to do, we will start heating. Once the temperature is increased by say 4 to 5 degrees Celsius, then we will note down the temperature. If initial reading is at say 28 degrees Celsius, then once the temperature reaches to say 33 degrees Celsius, that means temperature is increased by 5 degrees Celsius, then again we will measure time required to collect 50 ml of the oil. Then if we compare first and second reading, what will be the difference? Viscosity in liquids is governed by cohesive force of attraction. So when temperature increases, then distance between the molecules increases, then cohesive force of attraction decreases and hence viscosity decreases. So as far as time pattern is concerned, with increase in temperature as viscosity is decreasing, so time required to collect same amount of oil should be less in comparison with the lesser temperature. So as we go on increasing the temperature, viscosity of the oil will go on decreasing and hence time required for the collection of the same amount of oil will go on decreasing. This is what we are supposed to prove by performing this practical. That means how the viscosity of the oil is going to change with respect to temperature. Then as far as calculations are concerned, then diameter of the orifice, that is hole at the center at the bottom of the inner cylinder is 1.7 mm. Then how to determine kinematic viscosity of the given oil? This is the formula which is to be used for the calculation. Kinematic viscosity nu is obtained by making use of the equation C1T minus C2 upon T, where C1 and C2 are constants of the apparatus which are given provided by the fabricator. So for the given Redwood viscometer, C1 value is 0.026 and C2 value is 1.17. This nu is the kinematic viscosity in cm square per second, and the small t indicates time required for collection of 50 ml of the oil, which we have noted while doing the practical. Then once we substitute C1 and C2 in this equation, then new equation has become 0.026 t minus 1.17 upon t. That means if we look at this equation, Then we can now determine kinematic viscosity of the given oil once we note down the time required for 50 ml collection of the oil from the experiment. Then as we are having different readings of the time, we can find nu. Then how is the observation and calculation table? First column is the observation number, second column is temperature in degrees Celsius. We can either go on increasing the temperature or we can go on decreasing the temperature. Here trend of increasing temperature is shown. That means temperature is increased at the interval of the 5 degrees Celsius, 28, 33, 38, 43, 48 in this way. Then definitely as temperature increases, time value will go on decreasing, because with increase in temperature viscosity decreases, so time required will go on decreasing. Once this time value is obtained, then by making use of this equation, kinematic viscosity, that is nu, is obtained. That means what is our conclusion is that in liquids viscosity is due to cohesive force of attraction. So with increase in temperature, cohesive force of attraction decreases and hence viscosity of the liquids decreases. So as far as graph is concerned, we are supposed to plot the graph of nu, that is kinematic viscosity in cm square per second versus temperature. So definitely graph will be of this kind. So with increase in temperature, viscosity of the liquids goes on decreasing. Thank you.